Hello, Build. Woo. Welcome to the session on modernization of your applications with containers and serverless, where we are hoping to have you leave here looking at app modernization in a whole new light. Are you ready?
Yes.
All right. So here's the team that's going to be presenting to you today in order of our appearance. First, there's me. I'm Kamala Dasika, Director of PMM for Cloud Native and Intelligent Applications. The Microsoft co-presenters today with me are Jorge Palma, Devanshi Joshi, and Anthony Chu. We also have an exciting guest joining us, our customer, Barracuda. So our customer and I are going to have a discussion on their overall experience, detailing all the steps that they took when they were deployed as a monolithic application on-premise, what their design considerations were as they modernized to a cloud-native architecture, and their best practices that they employed to keep their developers productive and meeting the market. So let's get started. How many people in this room spend more than 8 hours a day on a device? Raise your hands. Pretty much everybody, right? I mean, we work in tech. How many more than 12 hours a day? That's quite a few of you. All right. So it's safe to say that's not too surprising, given that we are in tech. But this is a pattern that I've observed outside of tech as well. And what this means is that, pandemic or not, our world is still very much digital today. And the app is still very much the currency in this economy. So when the app is the storefront and the experience that follows the customer around through the entire process till you receive your goods or your transaction is complete, organizations have to focus on delivering high-quality applications that are fast, reliable, and accessible. So customer experience matters even more today in this digital economy because the switching costs for customers have gone down dramatically. We only have a few seconds to make an impression on a customer, differentiate ourselves through our customer experience, and that's actually a critical factor today in winning and retaining customers, no matter what your product is. Now, the worst part of it is that people only notice the tech when it doesn't work. We all know this. So while all of this attention on apps and development is great, the downside is that failures can be very consequential. And so innovating fast while balancing all of the cost constraints, the unpredictable end-user demand, and bringing along your legacy applications while also paying attention to security, all of that, pretty tall order. So thankfully, through the efforts of many developers in the open source, including those from Microsoft, Kubernetes, a cloud-native platform, has emerged as the technology foundation that modern-day applications can rely on. So what do we mean by cloud-native? The definition actually started with born-in-the-cloud companies like Netflix, but it has now really expanded to include all of those that are aspirational to the capabilities of the born-in-the-cloud companies. Now, I've shown here some of the defining features of this development paradigm and contrasted that with traditional application development. Some of those include application architecture patterns, like using microservices, composite applications that you can pull together and use APIs to kind of pull all of the application together. The deployment pattern is also different and features short sprints rather than waiting for all of the features to come together so that different teams can focus on getting their output to the market quickly, and adopting DevOps to release these features more frequently and without a lot of events that follow. So the operational patterns, therefore, are also adapting to this kind of development methodology. And the patterns basically favor heavy use of automation, cloud, and managed services, a pay-as-you-go kind of a model, infrastructure abstraction, and applying serverless model to think through getting your application to market quickly. So joining me now is someone who's no stranger to the app modernization process. I'm very excited that our customer, TC Gubatayao, is able to join us to discuss Barracuda Network's own modernization journey. Now, TC is Director of Software Engineering for Application Security and Cloud. He has been designing and developing software for over 20 years, 12 of those for Barracuda. Welcome to Build, TC.
Thanks, Kamala. It's happy to be here.
All right. To kick us off, why don't you tell us a little bit about Barracuda?
Sure. Barracuda Networks, founded 20 years ago, is trusted by over 200,000 customers worldwide to safeguard their employees' data, networks, and applications. We do this by building industry-leading security solutions that are highly effective, easy to buy, easy to deploy, and easy to use. One of those solutions that I would like to talk about today is the Barracuda Web Application Firewall service, part of Barracuda's Application Protection Platform. Barracuda's Web Application Firewall, or WAF, protects your applications by monitoring and filtering malicious web traffic. The WAF is typically deployed between clients and servers, where it proxies web requests and inspects inbound and outbound traffic for threats. Barracuda's WAF is offered in several hardware and virtual models. And as originally most of our customers' applications were on premises, the WAF was designed to support that. As Barracuda's customers migrated their applications to Azure, they needed their protection to migrate with them. So we released the Barracuda Web Application Firewall to the Azure Marketplace. And though deploying a WAF into your own subscription is effective, many of our customers told us that they would prefer a fully managed solution. After all, one of the primary benefits of cloud adoption is reduced operational burden. So we listened to their needs, and the Barracuda Web Application Firewall as a service was born. Our journey started with an initial service built on Barracuda's powerful and proven hardware WAF appliances and hosted in Barracuda's existing data centers. Here you can see the original architecture. In the center is Barracuda's data center with WAF appliances, load balancing and volumetric traffic filtering to support DDoS protection, and a management layer to control everything. On the right are the applications owned by Barracuda's customers, which can be deployed on premises or in the cloud. On the left are the end users of those applications. Customers configure application endpoints and update their DNS. And clients then connect to the WAF service, where their filtered requests are proxied to the backend service. This design was then replicated in Barracuda's data centers to form a highly available multi-region architecture.
So, TC, what prompted your move to Azure if you were already successfully deployed in your own data center?
Yeah, that's a great question. While the release of the service was successful, it was almost too successful for its own good. We quickly realized that we needed more of basically everything to continue to grow and meet our customers' demands. We needed more capacity in the data centers we had, and we needed more data centers to improve our global reach. Moreover, we learned firsthand that creating and managing your own data centers was challenging and operationally expensive. There were two main challenges: remote monitoring and scalability. We used IPMI and serial console servers for remote management, but we often found ourselves having to call the on-site personnel to help us check cables and do network troubleshooting. If you've ever had to talk to a relative over the phone and help them with their home networking issues, it was a lot like that. And scaling is even more challenging, as it requires extensive capacity planning. Shipping times, especially internationally, racking and stacking the equipment, the inevitable hardware failures, and trying to balance between over-provisioning and under-provisioning were some of the serious issues we encountered. And that's before we tried to expand to new locations. I think Tim Jefferson, Barracuda's Senior Vice President of Data, Networking, and Applications, said it best when he said, "Friends don't let friends build data centers." We started exploring other options. And as you may know, conveniently, Azure has 60+ regions available globally. So we worked with our partners at Microsoft and came up with a plan. From then on, we expanded into Azure.
So the first part of your plan, you were deployed into VMs, like a classic lift and shift?
Yeah, that's right. As you can see in this diagram, the architecture was modified to use Barracuda's WAF VMs and Azure native networking. We also extended the management layer to support these new cloud resources. We saw immediate benefits, especially with management and monitoring capabilities, as you would expect. And of course, capacity planning is much easier with the elasticity of VM scale sets. We're even able to provision entire new regions on demand with infrastructure as code. But there were still challenges. The core issue was that the unit of scale was still a VM, so the blast radius for software updates or VM maintenance was larger than we would like. Also, this lack of granularity affected our approach to multi-tenancy, which often resulted in uneven distribution of traffic and load.
So all of these actually sound exactly like the type of challenges that containers and Kubernetes could address.
Yeah, that's exactly right. Since we knew the limitations of VMs, this was sort of a stepping stone. We had worked in parallel to create a WAF container to run on Kubernetes. The containerization of software as complex as the Barracuda WAF was a significant effort. I believe it took twice as long as we originally anticipated, but it was well worth it.
That's great to hear. So did you manage Kubernetes yourself, or did you use the managed service?
Yeah, we chose AKS. Because even though I'm an advocate for DevOps, if I have a choice, I'd prefer to spend more time on dev than ops. With this new architecture, the pod was now the unit of scale. We were able to improve our multi-tenant design and fix a lot of the resource utilization issues that we had. Kubernetes supports advanced deployment strategies like blue-green and canary, and we use this to build confidence and release much more frequently. And the ease of versioning with these containers also allowed some additional benefits. For example, even though we had canary deployments, the unique configuration of customers' configurations and their network traffic might still cause problems that we didn't see with those. So we were able to use pinning of versions for that specific tenant while we resolved it and allow their traffic to continue. Also, another benefit was that the WAF images that we used for the service are the same ones that we could provide to our customers to run in their own environments. With this architecture, we have created a solid foundation on which to build that has continued to scale with our growth. The end result of our modernization journey with Barracuda WAF as a service is an elastic, global scale, cloud-native service that allows Barracuda to focus on protecting our customers from emerging threats.
That's actually awesome. So you mentioned that you like to spend more time on dev than ops. Are there other practices within Barracuda that you're using to keep your devs productive?
Yes. While AKS was the right solution for the WAF service, we use the service model quite a bit at Barracuda. A good example of this was a prototype for a new service that was built entirely with Azure Functions. Once the service demonstrated its value and gained customer acceptance, we realized that we could invest additional development into it. One of the things that we noted was that cost optimization was necessary. So we were able to migrate this service to AKS using Kata with minimal changes to the code. This reduced our compute cost by 80% using reserved instances, which we are better able to anticipate based on the known expected load. And in my experience, Azure Functions are great for a number of use cases. They can be used for rapid prototyping, especially for APIs. Durable functions can be used for most task-based workloads. And event-driven execution with scale to 0 means we don't pay for what we don't use. And anyone who has had to schedule automated VM shutdowns for evenings and weekends knows how valuable that is. Our teams are able to utilize the ability to execute functions locally within Visual Studio Code, using the extensions to quickly iterate and do development. They get a real developer experience, they can do breakpoints, and it can even connect to resources that are deployed in the cloud to consume those events. But if you do that, I recommend making sure that you ensure it's disabled before you re-enable the workflow. We have found that new members joining those teams are able to quickly onboard and get coding right away. This increased productivity allows us to get to market faster, all with minimal operational overhead.
That is awesome and great to hear. So the need for securing applications, I would imagine, has only grown, given the kind of environment we have today and the threats that we hear about in the news. What else is coming up on the horizon for your team?
Yeah, so threat intelligence is a really important focus at Barracuda. We want to derive insights from the data that we collect and use it to improve the security posture of our customers. We're also utilizing Azure AI services. For example, there's an app running in aka.ms that uses Azure Cognitive Search to identify sensitive data that is in corporate data shares. AI and data-driven insights it provides represent an exciting opportunity for us. And we're also exploring the use of other AI services like GitHub Copilot for our development and operations workflows. Anything that reduces cognitive load and automates routine tasks is a big win for developers.
That was awesome. Thank you, TC, for sharing your experiences. Really appreciate you coming down here and telling your story to the audience right here.
Thank you.
Thanks a lot.
Thank you.
So, some of you want to build a containerized application in the cloud, I hear, right? So that's just the stepping stone, really, for starting your cloud-native application development and operation journey. An enterprise app really is just code, right? And speaking of code, you can actually just use a lot of the tools and frameworks that Azure is making available for you. And from then onwards, let's reimagine the app development process with AI. So here's your code editor when you're building your application with GitHub Copilot. As many of you saw in Thomas Domke's presentation during the keynote, you can actually have Copilot do your boilerplate code for you. It can comment your code for you, and in general, provide a more readable version of what you intend to write as part of your application. You also saw that if you, in the context of modernization, inherited a piece of code, that it might be able to explain that code to you. Something that maybe your predecessor might have written. It might be an open source piece of code that you can write. And all of these tools are available to you as you build your new application or as you modernize your existing applications in your language of choice, since it supports several different languages. As you build your application, lots of data services as well as AI services from Azure AI are available for you to augment your applications. As TC was just mentioning, I think they used the cognitive search service from Azure as part of their application. OpenAI is available as a service through Azure. And from an operational perspective, when you are ready to deploy your applications, so many possibilities. And to go through that, we have Jorge Palma joining us, and he's going to take us through a demo of what some of these possibilities are.
Thank you. All right, so we've seen that we definitely want to ensure that we have intelligent apps. We also want to make sure that we have an intelligent service that can actually empower us to build those intelligent apps and to be productive. With AKS, we want to make sure that you are able to harness all the power of Kubernetes, the portability, the efficiency that it delivers, the scale that it has. But we also want to make sure that we bootstrap and create the necessary tools for you to be productive, for you to be successful, efficient at the end of the day. So we're really, really happy to announce the AKS Copilot, an AI-powered assistant for Kubernetes that will allow you to streamline all your operations. You're going to be able to say, well, how can I scale my cluster? Or what do I need to do in order to better monitor my application? It will allow you to reduce your skilling efforts. You don't need to choose, OK, do I need to go super deep on Kubernetes and have my teams learn or myself learn Kubernetes to the deepest level. You can actually choose and match what you want to learn when you want to learn it. With the tools we've built for code to cloud on the previous session, for example, you're able to actually deploy to Kubernetes without any knowledge of YAML or Kubernetes concepts. But even if you do want to have, you can go and learn that and still use AKS Copilot to tell you and help you build a manifest for Kata, for example, as we just saw, that can be part of your application. And you can leverage it to create the scaler for you. Maybe you know Kubernetes very well, but you don't know Kata. And you can use this to empower your developers. So you can focus on code. I think we just heard, focus more on dev than on ops. This is really what AKS Copilot is trying to have and to do for you as well. And as it's typically our custom, we're providing this for free for all clusters through the Azure portal. So let's take a look at what this actually looks like. So from a regular cluster, this is an AKS cluster. It's called Build AI. We're going to go ahead and we're going to jump into our workloads that show our workloads. And we're going to go into our typical create application with a YAML experience. But we're actually going to prompt our AKS Copilot. And we're going to go ahead and ask it to, hey, can you create a deployment for the image AKS Hello World for me and create a service for it? It will generate an answer for you. This answer actually has a YAML in the answer, so you'll actually automatically populate the editor on the left with that manifest. You could go ahead and edit it. It's actually pretty amazingly correct. Has 3 replicas for it. For our image, it's exposed port 80 because it's a web app, and it created a service that matches port 80 to port 80 on the target port. Thank you so much. Yes, this is pretty cool. This is pretty cool. So you can just go ahead. It defaulted to a load balancer. You can go and change this, to a service, to a cluster IP or whatever you want, and you can just deploy it and see it actually working. So we can, take a look at it. You see it's deployed. Everything is running fine. It came from MCR. It's a good image, and it's already running. And now we can just, confirm that this is all working. There's no magic going on here, and we can access the service right here through the IP, and everything is working perfectly fine. There's a little bit more, right? Okay, this was nice. It helped us get started. It helped us deploy an application. But I promised, help with operations as well. So let's assume that we actually want to take a look into, okay, is my cluster fine? Is everything okay with my cluster? So you can just go ahead, pop Copilot on the overview blade right away and ask it, hey, can you help me get a query for the minimum, the average, and the maximum, CPU usage for my nodes? And it will go ahead and actually create a query right there for you that you can very easily just copy, go into the experience for log analytics that we have straight up in the AKS portal. We can actually bypass the recommendations because we already know what we're going to do. We just paste it, run it, and you'll immediately see that query give the result for the minimum, maximum, and average for all nodes. You could not know any KQL. You might have just turned on monitoring, and you just needed some help create this query. This is not a super complex query, but it could help you with much more advanced queries. You can now go ahead and say, maybe there's something a little fishy with my nodes. I actually want to go and see what's consuming this CPU. So you could go ahead and say, hey, OK, I want to change my target here. Can you tell me what's the minimum, maximum, and average of my pods? And once again, Copilot will give it some thought, and it will generate that query for us right there, and we can go ahead and paste it. You could ask for anything. You could ask, hey, can you give me the P90 of all my containers? Could you give me, how I can scale my cluster? Could you tell me how to generate a manifest for Kata? Anything that you want. And we can just go ahead and paste it right there on the screen and see the access for all our pods in that case. So you can pop into any of them. In this case, it's for example, our metric server, and several other pods that we actually have there. So what you see right here, we have a full session on it yesterday that I definitely would encourage you to check on demand. We show you how to do that from the development process itself, how to do all these operations. We also have several open source projects that you can try out, like kubectl AI, that will bring this experience as a kubectl plugin for your CLI, as well as kubecopilot that will actually help you within the cluster and within kubectl to actually diagnose problems and see any issues, or execute commands like, hey, tell me which one of my node is better suited for receiving my next deployment, and it will actually tell you that exactly. Hope you're as excited as us to take a look at this and to actually play with it. We expect to ship it in the upcoming months for all of you to have access to, and we expect your feedback, and we expect to continue to deliver for you all the Copilot experience. Thank you so much.
Thank you, George. That was awesome. So as you can see, leveraging AI in app modernization, kind of possibilities today for your applications. All of the various cool things that you can do today with AI, like sentiment analysis, text comprehension, risk modeling, every type of application that's probably deployed today really can get a little bit of an assist, just like those who are creating the applications, deploying the applications, are getting from AI-assisted co-pilots. And a couple of other things here we talked about today in terms of additional assistance that developers can get in terms of their modernization experience and just getting their prototypes to market quickly. Serverless is certainly emerging as a great technology. And for that, I have my colleague Devanshi Joshi, who is going to come forward and explain to us and take us through some scenarios about serverless. Devanshi.
Thank you, Kamala. OK. Hi, everyone. I'm Devanshi Joshi. I'm the product marketing manager for Serverless in Azure. So now, as you modernize your application, you're infusing AI and working with real-time events and data sources. Applications are event-driven, reacting to triggers in near real time with some unpredictable and bursty traffic. So being a perfect fit for serverless architectures. For example, millions of events from different devices stream into a hub, processed by serverless compute, and stored in a relational database for further analytics, or maybe on an analytics dashboard view. Or you are having a scheduled processing task coming through, including batch processing. You have some backend workload for web or mobile backends, even IoT backends, or AI/ML, real-time bot messaging that you're processing. So overall, an app architecture often needs to run parallel executables to your core business logic. And this way, you're maximizing your compute cycles, running these asynchronous tasks, while your core app is focused on the main function. For example, you have a car insurance claim application. The user uploads the car damage image, and the main function of the app is to process the claim. But there can be several tasks associated with this user action, like, for example, compressing this image and storing it up in archive for further reference. So while that image is uploaded, the main function still remains to process the entire claim and verify and validate the user request. For such scenarios, I'm happy to announce Azure Container Apps jobs. I now invite Anthony Chu to take us through this.
Hey. Thanks, Devanshi. Yeah, so yesterday we were happy to announce the public preview of Azure Container Apps jobs. So Container Apps is a serverless containers environment for running applications and microservices. And you're able to run applications like web servers and APIs and some background processes services that run for a while. And jobs allow us to run containers that run and does a little bit of work, or maybe a lot of work for maybe minutes or hours, perhaps, and they exit. And you're able to run them on demand. So this could be through an ARM call or through the CLI. And a good example of this could be like a one-time migration. Like you want to migrate some data from one database to another. You can create a job, and then you kick it off, and then you can just run, and then it finishes, and then exits. And you only pay for the seconds that you run it for. You can also run them on a schedule. So that's pretty self-explanatory. You can provide a cron expression, and then you can run a job anytime you want. And multiple executions of a job can run simultaneously, so you can actually get pretty good scale out of them as well. And lastly, we have event-driven triggers for jobs as well. So you can sort of imagine jobs that are kicking off by queue messages. So you want a job to run for each message that's in the queue. So there's a way to run that. And that's all powered by Kata. So I'm going to show you a demo of how this works now. So this is a very basic Python script that I wrote. And it all does is that it can pass in a video URL, or it can actually go reach out to Service Bus and get a message, and it has a video URL in it. And given that video URL, it's going to download it, and then it's going to run OpenAI's Whisper model and actually do it, perform a transcription on it so that you can actually get speech to text, and then output that text. We're not just printing it out to console log, but you can, you can imagine kind of outputting that to blob storage or something like that. And to create this job, I can use the AZ CLI, the Azure CLI, to do this using this command. And there's a lot of stuff going on here, but I'll just kind of quickly point out a couple of things. Here I am going to create a job of trigger type manual so that I can kick it off myself anytime I want. And then I can provide the image name that I had before. And then I'm setting the video URL. So that's going to run, download this video, and then transcode it. So I've already run this command to create it, and I'm going to run this command here to start an execution of that job. Just like that, the job execution has started. So I'm going to flip over to the Azure portal and take a look at what a job looks like there. I can click into the execution history, and you can see that a job is running here. That's going to run for a few minutes, so I'm going to click into the logs for a previous execution. And if I scroll over and expand this a little bit, you can see that it actually transcribed one of the videos about container apps. And then if you remember that the script that I wrote can actually pull a message off of Service Bus and basically do the same thing, but get the video URL from a Service Bus message. So let's see how we can use that as an event-driven job. So very much like how we ran the command to create a manual job before, an event-driven job adds a few more parameters, but they're mostly related to scaling. So there's a couple of things that happen when you run an event-driven job. One is that every polling interval, in this case, I'm setting it to 20 seconds. It's going to execute the Kata scaler and actually look at my Service Bus queue in this example. And it's going to see how many messages there are. And in this case, I've configured it to kick off an execution of my job for every message. And then for every execution of the message, my script will start. And it's going to go and reach out to Service Bus and pull exactly one message. And then it's going to get the video URL from that and execute it. So let's see what happens when we do that. So I'm going to go ahead and grab a URL. And I'll head over to Service Bus. Oops. Oh, I was in. There we go. And then I'll just paste this in here. And then normally you would perform this on different videos, but I'm just going to do this on the same one 20 times. So I've sent 20 messages to the Service Bus queue. And then now I'm going to head over to my job. Which is right here. then we can take a look at the execution history here as well. And you can see that the 20 jobs have started. And like the previous one, it's going to take a little while to run. But you can see that I can run 20 of them in parallel pretty easily. And lastly, I'm going to take you through an example of how a container app can interact with a container app job. So here is an ASP.NET Core application that you can run, that I have running as a container app. It's a pretty simple application. The idea is that for this fictitious company, every time that it onboards a customer, it needs to run a bunch of processes behind the scenes to actually like read some data or load some data into a new database, provision infrastructure and things like that. And it can use a job to do that. So in this case, we're using a manual job. So, and then with only a few lines of code, like you see here, we're getting a managed identity, and then calling the ARM API. I'm able to actually kick off a job execution whenever somebody executes this API. So, so this job can run for minutes or maybe even an hour, and it can do all the things that it needs to actually onboard that customer. And in order for me to pass in the customer name, I can actually modify the job definition for this specific execution so that I can pass in the customer name here. So that's what I'm kind of doing here in this post. And this is what the application looks like. I'm just going to quickly refresh it. And we can go and onboard a customer. So what's another fictitious customer? FabricCam. And add that. And then maybe we can do it for Contoso as well. Oops. And then you can see behind the scenes as the jobs kick off, they're actually running. And the advantage of running these jobs in the same environment as your container apps is that they can talk back to the container app and tell it how it's doing. So you can see as the jobs are progressing, it's actually updating in real time on this UI. And also for this app here, they also have some scheduled jobs running in the background as well. So we can list them off here by calling the application here is calling the ARM API to list off all the scheduled jobs that are running every few minutes. So, so that's how you can combine Azure Container Apps and the new Azure Container Apps jobs feature to build pretty complex microservice applications.
All right, thank you, Anthony. That was super cool. So, okay, here's a visual of what just happened in the demo of how user requests hit the container app, and then it kicked off a bunch of jobs, event-driven, scheduled, and on demand. Okay, so as you write your application in real-world scenarios, let's move on to what's the next task for you to hit, like, for example, workflow orchestrations. Durable functions, an extension to Azure Functions, helps you simplify that complex stateful or coordination requirements. And behind the scenes, it's managing the state checkpoints and also restarts for you, allowing you to focus on your business logic. These 6 patterns are the usual patterns you would try to employ as you design your orchestration. First one being sequence of events. So a sequence of functions trying to execute in a specific order with chaining. Or it can be coordinating the state of operations with external clients. Like, that could also include long-running functions. So with HTTP APIs, there is the fan-in and fan-out as a structure, where at the end of parallel execution, you may want to aggregate the end result. Next, we have monitor. So you may be wanting to monitor a long-running function, for example, and take an action out of it. For example, periodic table cleanup, maybe. There could also be human interaction involved, especially along the approval processes. You could have an escalation path in parallel when the human is not able to respond in time for immediate action. And lastly, the overall event aggregation. Events could be coming in from different event sources. So a function combining all of them together in a batch, and having the end user interact to the cleaned up event set. The serverless and Azure landscape starts with a core using Azure Functions and Azure Container Apps. As you consider developing applications, note the end-to-end application ecosystem where serverless enhances the overall journey for your solution. You can easily integrate it with incoming events, as well as leverage the broader API economy, internal or external to your solution. You enrich your application with data, and you process them, either updating the data or getting insights out of the data, leading into analytics to fuel that inferences, maybe. And lastly, we have that tinge of AI and ML, and going forward with IoT applications to power your applications. So you could be either running those models or processing those models for intelligence that drives your further solution drive. Lastly, this entire Azure landscape for serverless can be deployed against other app types like aka.ms or app service together for your entire application architecture. And overall, you can go out to extend it to external APIs outside the Azure platform, including Kafka, Elasticsearch, Power Apps, or even through Arc. So process your events and data just the way you like it and where you like it. For application lifecycle management journey, secure supply chain is critical. And as you develop and test your apps, choose the code platform that suits you best, your dev tools of your choice, like VS Code. Deploy it using GitHub Actions to your target environment. And once deployed, go ahead and monitor it out for consistent performance. Use App Insights, use Log Analytics. Go ahead to manage the end-to-end solution architecture components through Azure Portal, through ARM templates, and provision governance overall with Azure policies. All of you here today are from some industry, some vertical, developing applications that's tailored to that industry and vertical for a variety of use cases, whether it's the retail industry, where you're involved with inventory management, or you're with automotive industry doing predictive maintenance, or just banking doing document processing. There is a difference that containers and serverless can make to your modernization journey today. So it is your time to modernize and bring your apps to market faster using containers and serverless with built-in security and a diverse application ecosystem across data, AI, and observability. Services like Azure Kubernetes Service, Azure Container Apps, and Azure Functions abstract away that common developer challenges, like managing the infrastructure, to deliver a more seamless and productive experience. It's all about finding the right balance between control and productivity for your app. So to help you get started on your modernization journey, we have Azure Landing Zone Accelerators. Leverage these ready-made base architecture design to deploy with best practices already baked in. One available for Azure Kubernetes Service and one for Azure Container Apps. So, are you ready to modernize your applications? I know you are. There are a whole bunch of other sessions and labs to help you dive deeper, but join us for a Q&A right after this on-site on room 444, and also digitally. We'll take all your questions there. Thank you. It's been a pleasure, and can't wait to see what you bring with your modernization journey. Thank you.